This is the Pineview Robotics Camp. This is the very first year we've been able to offer this camp. This is for grades 5 through 9, grades 11 or ages 11 through 15. This was sponsored by the Pineview Association, which is the Parent-Teacher Association for Pineview School, and the Fallhaber Foundation. These kids are going to be using the Lego Mindstorm series robot package. Every day is going to be a competition where the kids have to design and build and test and program a robot to go through a specific obstacle course or do a specific challenge. This is a big hot toy right now, and that's what's great about it, is that it's a toy to the kids, but it's extremely educational. It teaches kids about computers, about programming. You know, it makes them think, it makes them problem solve, it makes them do all those things we try to do in a classroom, and we just, you know, push to try to get the kids to do higher order thinking, problem solving. You know, employ the scientific method, and with these robotics kits, they are employing the scientific method without even realizing it. They're just having fun. They're working really hard, and they come up with stuff that they'll blow you away. The kind of stuff, the level of sophistication that children are able to do whenever they are really actively engaged in what they're doing. They get so wrapped up in this that, you know, they're able to program a robot to go through an obstacle course that you know, you would expect to see at a university level, and they're 11, 12 years old. Their minds they're very flexible. They're able to think outside the box because they're young enough where the box is still forming, I guess, if you want to say it that way. And so they're able to figure out ways around the problem that someone who's spent 20 years programming probably has, you know, in their mind 4 or 5 very well-defined approaches to solve this specific thing, and they'll come up with things that you and I wouldn't have come up with. When I was their age, because I like them, I guess, you know, and but I actually had to, you know, program an actual computer, and I wasn't doing real fun stuff with it. I was, you know, just little programs that you can do when you're 12. I didn't have something like this. I had programmed computers and had tons of Legos, but I didn't have Legos to program. So.
This is a computer. You know, this thing here is, you know, computing power like an iPhone, and expensive like an iPhone as well. We've got 2 servo motors, a light sensor. There's also a sound sensor and an ultrasonic sensor, and they're going to have a challenge to use each one of those sensors. And so the challenge at the very end of this, where we have an exercise to use each one of the sensors, is going to be where they have to go into a burning building, which there's smoke in it like it's dry ice, and so then they have to use the ultrasonic sensor because anything to do with light wouldn't be able to go through the smoke. So here it is, guys. We've got a lot of stuff planned. My name is Mr. Gleitz. Some of you guys know me, some of you guys don't. Most of you guys at least know of me. I'm a science teacher here at Pineview. You are a very special group because you are getting to be the very, very first group of students to go through this robotics camp. This camp uses the Lego Mindstorm. Just raise your hand if you've played with the Lego Mindstorm before. All right. You guys that have played with it before, you know it's absolutely awesome. It's a lot of fun. This is the base robot. You're all going to be working in pairs. You'll each get one of these. First thing we're going to do this morning, we're going to talk a little bit about robotics, and you're going to put together your robot, and you get to name him, and this will be your friend from now to the rest of the week. This is Miss Amanda. You want to go by Miss Amanda or Miss Peterson? Miss Peterson. Okay. So Miss Peterson, she has a robot that she has programmed.
In 2 seconds. It's just going to come out and say hello.
Second morning.
The very first thing that we're going to learn how to do is we're going to learn how to build our robot to start here, come up, get infinitesimally close to these bottles. That means get as close as you can without knocking them over. Whoever gets the closest without knocking them over wins. That's learning how to go forward. This right here is learning how to make very, very sharp right turns. You gotta go forward, make a very sharp turn, and stop. That's the two basic things of the robot that we're gonna work on today. A lot of you guys already know how to do this. You'll be able to show us that you can do this, test out of it, and move on to the more interesting thing. The more interesting thing that we're gonna do at the end of the day and tomorrow is this obstacle course. You gotta go start here. You gotta move through the obstacle course without knocking over any of the bottles. Okay? If you get through the whole thing, you can then come over here, and this is Robot Disco. You make your, if you want to show off, you make your robot spin in circles. You get bonus points for that. Okay? So lots of cool stuff. Let's get started. All right. You get to pair up as you choose. We want one pair per computer. Yep.
So we're all really excited that we're going to get to do this, and this is really cool that you guys get to see this because I think there's only one other time in my life, I remember back in college, that we had some liquid nitrogen and we got to do a lab with it. But other than that, I've not gotten to do this stuff, and I've been wanting to for a long time. So this is really, really cool. I've been looking forward to this for quite a while. Liquid nitrogen is awesome stuff, and you guys are really lucky that we have an opportunity to see this live. So I want to introduce to you all, this is Jill and Doug of Sub-Zero Ice Cream. Thank them all for coming. Feel free to capture some of this stuff on your personal devices if you'd like. They have a list of things that we've worked together. Mr. Dacey and I have worked together, mostly Mr. Dacey, to come up with this sign show for you. So this is Jill and Doug. I'm going to hand it over to you guys. We'll let you get going.
All right, thank you very much for inviting us here. We own the Sub-Zero Ice Cream shop on Siesta Key in Siesta Key Village. We've been in business for 5 months, so this is somewhat new for us as well. But a couple of these tricks are very cool. They bring a science component into our business. I'm a civil engineer by training, so this really got my attention as I was looking at ideas for a new business venture. One of the first tricks I'm going to do is a fairly simple one, using this balloon. And the question I have for you is, what's going to happen when I dramatically change the temperature of this balloon, of the air inside this balloon? Yes?
It's going to get smaller.
It's going to get smaller, that's right, because as the temperature goes down, pressure and volume are going to go down. So another person asked the question, why did I put my hand in liquid nitrogen? Liquid nitrogen is so cold that it actually runs away from my skin. It doesn't want to have prolonged contact. If I held my hand in there for over a second or two, I would get frostbite. But because it's just a very quick touching of it, it just rolls off the skin. It's called the Leighton-Frost effect.
Oh, yeah.
She usually gives this part of the presentation.
I saw that on Mythbusters when they put it in molten metal.
Right, right. So anyway, we're going to do the demonstration. As I reduce the temperature of the balloon, as you described, pressure and volume also decrease.
You know what gas is in that balloon mostly?
Yeah, that's a good point. The air that we breathe is only 21, more or less, percent oxygen, 78% liquid nitrogen. So this is the balloon, and as my hands warm it up, it's going to come back into shape because as I raise the temperature, what happens to pressure and volume? They increase. It's called the ideal gas law. I'm not sure you guys have gotten into that at your stage, but PV equals nRT, and we ignore N and R. So PV equals T. And there you go. The balloon is back.
Let's dip it back down in there and have them toss it around.
Okay.
Do that?
Yep. Get another balloon.
Look how the, hear what happens to the rubber?
Yeah, these are a good quality balloon. Some balloons are just great.
Right now, by the way, the liquid nitrogen in those containers is boiling away.
Right.
Boiling.
No, we won't be exploding the bottom.
If we put the cap on there, it would explode.
Could you guys be quiet? If I can put the cap on here, what's going to happen? As the liquid goes to gas, does it expand or does it contract? It expands 600 times for liquid nitrogen. So if I put a cap on, and believe me, I did this inadvertently one time.
It's funny.
It goes and shrapnel goes everywhere. So we will not be doing that trick. However,
Because we like you guys.
here we can do this because we're not restricting the expansion of the gas. Now, how do you think I could speed up this balloon?
Put more in.
Somebody else.
Put more in.
Put more, well, I could put more in. That's true. But what I'm going to do is back to the whole temperature thing. This is just room temperature water, but it's making it the temperature change much faster.
It's gonna pop.
It'll pop or it'll fly off.
Can I have that? I want it.
All right, so I haven't done this actual type of flour before, but I've basically frozen the flour
We've never
so that
Oh my gosh. You're killing
fairly simple concept. We froze it and it shatters because it's a solid structure.
It's gonna turn it into like I know, right? It's gonna go. Is it bigger? What a rose? No. Dump it into the. I'm gonna keep that. Let it fall on the floor and break? Yeah.
It's gonna be broken. We don't want to do that.
Yes, we did.
Break anything.
Is love strong enough to save this rose?
No.
Are you sure?
Yes.
Are you sure?
Yes. It's strong enough. Drop it.
Well, I gotta make sure all the liquid nitrogen drains off, but I don't think I want to eat that.
Oh, you're gonna eat it. Drop it. Yeah. Can I eat it? You're gonna eat it? Smash it in the wall. Watch what happens. It's so cool. Can I have it? Mr. Daisy.
Mr. Daisy. Smoking.
It is so hot.
No smoking in the pool?
Right there. Do you want my
That was a cold grandma. There's a banana that's been soaking in the liquid nitrogen for a little while. I just got this banana at the grocery store. It's an ordinary banana.
Try to peel it and try to peel it. Oh, you're a nail and a nail.
Almost. Solid.
Try the other piece.
There's a little bit of a core there that didn't freeze because it didn't leave it in long enough. But,
Can I have one of the pieces of banana?
You're able to start. You got that nail.
Okay, so this is down to the wire. Our students have spent the past 4 days practicing the very specific capabilities of their robot. We've had a challenge each day that uses a specific feature, a specific sensor to a specific task. And now this is a challenge that involves using all the sensors and doing all the tasks. So what we see over here is we have a burning building, and that's part of the theme of the camp is that we had a day of science demonstrations that involved fire, and they have a science demonstrations that involve ice, so like liquid nitrogen and exothermic reactions. And so this is the fire and ice themed challenge, where the robot is supposed to be like a fireman, and it's going into this burning building, and it has to knock over these bottles with candles on them to put out the fire, and then it has to rescue a little man in there and deliver him to safety. As you can see, there are these bricks for obstacles, and they have to use the light sensor to follow the guidelines.
It's been fun. I like it.
You don't have to do tricks.
I know, it's just for fun.
Frustrating at times because
I know, it's
they don't do what you want them to do.
Well, our robot is named Mr. Chow from The Hangover, and Carlos built this machine gun, and he has his armor, and this can pick up things, and then he has a touch sensor where it can go around objects and avoid them. He has an ultrasonic sensor that detects distance. And Carlos also designed the wings on here that knock down all the water bottles. And then
Kind of like 2 motors so it can run kind of like efficiently.
it's fun. The robot doesn't always have to do what you tell it to do, but yeah.
It's fun, like kind of building it, programming it.
Lots of competitions and challenges to face using all the different features of it.
And like each time we added on one more feature and used past features to like build on like activities and other things.
Well, one of the parts is rescuing the person. So I'm trying to make, this is to push it out, but sometimes it gets below. So I'm trying to build these to block it from the wheels so it doesn't get jammed.
First, within this, we had some really awesome science demos. So Mr. Dacey and I, mostly Mr. Dacey on this one, thermite is a chemical reaction that burns extremely hot. And so we demonstrated that outside, and we got the product is iron, but it's so hot, it's a molten stream of iron. And we caught that in a bucket with sand, hopefully to turn siesta key sand into glass. It worked, sort of. We were happy with that. So that's the fire part. And then the ice, we just had Sub-Zero ice cream. It's an ice cream shop that cools their ice cream with liquid nitrogen. And so they came in, and we did a liquid nitrogen show today. The kids got ice cream. I think they liked that. What'd you guys think of the liquid nitrogen today? You missed it? Oh, okay. Well, so that's fire and ice, and so we got to keep this cutesy theme. So this mission here is the robot is like a firefighter, and he's got to follow this tape to go into this burning house. And there's these little tea lights here on these bottles. You got to recycle the bottles, use them every time. And the tea lights on the bottles, and he's got to knock over the bottles, and then he's got to rescue the little man on this. And of course, avoid these obstacles. And these are the evil robots that started the fire. And you gotta go knock over the robots, get around the obstacle, get to the winner's circle, and do a victory dance.
They have to touch the obstacle and then go around it.
Well, by the way, every one of these robots worked better when they were testing it than how it's going to work right now.
Literally, like we have the data to back it up. We watched,
We've seen this in action.
we watched every single kid get through this when they were practicing, and then only 20% finished whenever it happened. So I thought robots, you know, they didn't get happy, they didn't get sad, they just run programs. No, apparently they have jitters and they have stage fright, all kinds of stuff like that. Okay. And 3, 2, 1, start.
I'm ready.